and section 6.4, two sections that deal with the hard ones. Now the hard ones, the numerical coefficient of the squared term is not a 1. Like I said on the previous page, it's not a 1. Like right here, that's not a 1. So it's more challenging. So what do I say? First, make sure the trinomial is in descending order of power, because if it's not, it's going to be impossible or feel impossible, and you might be led to say prime, when in fact it's not. So make sure it's in descending order of power. Is this one in descending order of power? Yeah, it is. You know, the power of 2 is first, the power of 1 is last, and the constant's at the end. What's the degree of this? 2. What's the degree of this term? 1, because there's a 1 right here. Okay, what's the degree of the last term? 2, 1, what's it's got to be 0. It's true, 15x to the 0 power. I mean, I would never write x to the 0. But what is anything to the 0 power? 1. A little review of chapter 5. You know, this is the same as 15 times 1. So that's, what's the degree of this term? 0. Degree of this term is the same thing. 0, 1, 2. Numerical coefficient is 2, makes it harder. So this first method in 6.3 will say factor off the GCF if there is one. Okay, so no, there is not one. There's no GCF. Okay. Next, write down 2 parentheses and place the appropriate signs in them from the sign chart. Okay, so here I'm going to write down 2 parentheses and put the appropriate signs in there. Well, plus plus is a plus plus in your sign chart. Check it out. It's true. Okay, now here comes the difference of the last of the easy one with this one. You're going to list all the pairs of factors for the first term. Oh, right here. See, you're going to, just like over here, we listed this as what, 1 and 15 and 3 and 5. You're going to list the terms, the choices for 2, which is only 1 pair. 2 times 1, 1 times 2. It doesn't matter which order, like that. So this says list all the pairs of the factor of the first term and choose one of them. Well, there's only 1 pair. So going to choose a pair. Okay, I choose that. So there you put a 1 right here. There's a 1 right there in front of the X. And there's a 2 right there. So stick them in there. And you choose something. Well, what do I mean choose? Okay. Here in the easy ones, you pick the pair that gave you the middle term, right? You pick the pair that gave you the middle term. No, you can't do that when there's a 2 out here. You can't do that. Because you'll look there and you say, well, there is nothing. That's going to be 8 or 2. No, I can't get 11. I can't get 11 with just that. You've got some extra stuff to have to deal with. It's not the easy one. So I'm giving you a method that hopefully you'll say, well, okay, I'll try it. Might make sense. If it doesn't make sense, then I get method number 2 coming up, in a few minutes. So list all the pairs of the factors of the first one, choose. List all the pairs of the factors of the last term, choose. Choose something. So what I did is I said, okay, I'll choose that one and I'll choose that one. Just choose, because you don't know which one yet. See, here's your choices, 1 and 15, 3 and 5. Choose. Okay, I chose this. I chose that. Stick them in there. And then what you have to do is do a check. You do have to do the FOIL to see if you get back to where you started from. You don't want to stop and say, well, I guess I found the answer. Not necessarily. So all you really have to do is check the inner and outer. Why don't you check the first and the last? You could, but you picked the first and the last numbers specifically so that you would get 15 and you would get 2. I'll say that. You pick the numbers so that you get 15, you get 2. You picked them. So there's really no need to check the first and the last on FOIL. Don't need to. But if you wanted to, you can. So all I'm doing here is look at the inner and the outer. Okay, there's the outer, there's the inner. 17x is not the middle term. That's what you're trying to do, is come up with the middle term, 11x. That's not it. So you pick pairs that didn't go together. So what you're going to do is try it again. Back up here, my instructions say list all the factors, choose one. Check to see if the outer and inner terms of FOIL give you the middle term. If it works, then you're done. If it doesn't, then you have to keep trying different pairs until you get the correct middle term. Seems like a mess. I know, it seems. This is this method, I guess I call it the traditional method. The book doesn't. I call it the traditional method. For years and years and years, this was really the only way to do it. And then, gosh, I'm thinking about 25 years ago, even when I taught high school, this next method was not in any of the books that I used, none, or I was given to use. This next one, until I got to the JC, and all of a sudden someone says, "Wow, Mr. Clark, how about the British method?" I remember that, Jan. I don't know if I ever told you that story. The British method. Had a high school student say, "British method." I go, "What are you talking about?" "Oh yeah, this thing called the British method." And it's basically the grouping method. I have no idea why someone would call it the British method. It has nothing to do with England or whatever. It's a grouping method. So the 6.4 takes the same problems and creates 4 terms so that you could use the grouping method. And some of you like grouping because you know the process. So wait, then 6.4 is coming. You might like doing that so much better because there's a nice structure to it. This one just seems like trial and error, guess and check. I don't know. Keep doing it until I get the right one. And maybe I don't get the right one. And then the answer is prime. It just seems so abstract to me. Back to this one. It didn't work. So try something else. Try something else. What do you mean? Try a different pair. You remember the first ones that number 2 only has there? Okay. Or when I say a different pair, I guess I probably didn't say that in here. If not, then I need to add to my instructions next time. Check to see if the outer and inner terms give you the middle term. If it works, you're done. If not, you have to keep trying different. Yeah, I think there's a little extra piece in there. If not, then swap the back terms. Swap the last terms. Yeah, I do. Okay, swap the last last numbers only. Numbers only. Jeff, what do you mean by that? Okay, because it's on the next page. This didn't work. If I swap and Jeff, you might say, well, why did you put the 1 and the 15 there? Couldn't you put the 15 and the 1? And yeah, there was no reason that I put the 1 and the 15 because they're both the same sign. What about the 1 and the 2? Why couldn't I put a 2 and a 1 there? Could have. If I took the 15 and the 1 and swapped their position, would I get a different outcome? Yeah, usually you do. Oh, maybe you would have gotten the 11 that way. So that's why I'm saying if it doesn't work the first time, swap the last numbers only. I always pick the last numbers and check it out. See, I put the 15 and the 1 in a different place, and then I get ultimately 31 when I check the outer and the inner, the O and the I, outer and inner. And it's still not 11x, so that still didn't work. So then what you do is pick different pairs. So I picked the 5 and the 3 instead of the 1 and 15, 5 and the 3. Jeff, why are you putting 5 and 3? I like smaller to bigger. Well, then put the 3 and the 5. You're just trying to find a pair that works. So I left it as 1 and 2 and then put the 5 and the 3. I just tried it that way. Inner, outer. Okay, inner, outer. 3x, 10x, 3x, 10x, 13x. That's not the right number. All right. So then my modified red instructions back here said if it didn't work, then swap the last numbers only because you're probably going to get a different result. So I took the 5 and the 3 and put it as 3 and the 5 and did the inner and the outer. Inner is there, outer is there. Ding, ding, ding. That's the answer. That's the good thing. That's telling me that this is your factored form. I'm not going to say it was easy. I said it was going to be hard. It's going to be messy. And when these numbers get bigger, it gets even worse. When I say bigger, remember the first one I just did had the numerical coefficient of a 2. There was only one choice. I have more choices. I have, okay, this one here, I got 1 and 15. I got 3 and 5. Great. Which one am I going to pick? I don't know. Pick something. Pick 2 and 4, sure, or 1 and 8. I don't know. Which one do you want me to pick? Anybody have a favorite pair? I'll put the X. Anybody have a favorite pair? Which one of these you want me to pick? Anybody can choose. I don't know what the answer is, so someone pick. Okay, Jan, you pick.
3 and 5.
Okay, 3 and 5. Okay, so but 3, just the way she spoke it, 3 and 5 in that order. Okay, Jan, pick a pair.
8 and 1.
8 and 1. Okay, the way she spoke it, just put it in that order. Okay, sign chart. Negative, positive. The sign chart, negative, positive. Hey, they're both negative. Okay, so both negative. Now I have to try the, I don't know, you want to try the whole foil? You don't have to. Yeah, let's try the whole foil. Okay, there's 15x squared. Well, goody. It's gonna work every time. So, okay, fine, foil. All right, there's 15x squared. Okay, the outer and the inner are the important ones. So I'm gonna write it in red. The outer is negative 3x. The inner is negative 40x. And the last is positive 8. Okay, big deal. It's gonna, your first and the last will always be true. It's in here that's important. Do you see negative 22 coming out of this?
Nope.
Jan?
Nope.
No. Oh, forget it. That doesn't work. Scratch. Not good. Okay, try another one. Jan, according to my rules, if my rules kind of made sense to you, what would I be doing next?
So we'd have 3 and 5, and
Okay,
then
so 3x and 5x, leave those alone.
Let's try 2 and 4.
No, before that.
Oh, 1 and 8.
Right. Remember, in red, I wrote it over here for everybody. So I said, if it doesn't work, then I modified this, then swap the numbers before you do different pairs. Swap the back numbers. Before you try it, because otherwise it's like trying to keep track of all the different combinations. You might lose track. You might not even like this method, and that's fine too. 1 and 8. Yeah, 1 and 8. 8 and 1, 1 and 8. Well, Jeff, why couldn't I do 5 and 3 at the same time? You don't want to do a pair at the same time. Oh, okay, fine. You don't blame me. What if I, because you'll get right back to where you started. You just do one pair, not both pairs. Okay, Jeff, what do you mean? What if I did the 3 and the 5 what if I swapped the 3 and the 5 and the 1 and 8 at the same time? So this is 5x, and then this is a 1.
And then 3x and 8. Yeah.
Well, that's the same thing. See, that's just the same thing. Yeah, you don't want to do them both. You pick. Well, Jeff, could I just swap these and left those alone? You actually could have. You could have 1x and then this is 3x like this, and then leave this as the 8 and leave this one as the 1, because that looks different. Well, that looks like the same thing as, oh, hold it. I did it wrong. This is, hold it. This is 5. That's weird. Yeah, leave. Jeff, what are you doing? Swapping this, leaving that alone. Yeah, okay, that's right. But that looks the same as what I was just doing over here. I'm just picking either the front or the back, one or the other. All right, so both of them negative sign. Okay, inner, outer is really all you need to check. Minus 5x, minus 24x. Add those together, negative 29x. Doesn't work. Didn't work. So you think I'll say, well, fooey on it, it's prime? Not yet. You have to try all the different combinations that are out there, and that's where it gets challenging. Try something different. Try something now, something different. Okay, Jan, give me something different.
Okay, let's do 3 and 5, 2 and 4.
So she's staying with this, but instead of the 1 and 8, she's picking that. So those are different pairs. So let's try that. 2 and 4, 2 and 4. They're both the same sign. Do the inner, outer, inner, outer. I think she's got a winner because that's negative 10 and negative 12.
And you can give Randy credit for that because she guessed it.
Good. So then she might like this. Brandy might like this technique because sometimes some of you can see ahead of time the combinations that will work. Sometimes your brain, some people's brains can see that's like a puzzle. I can get that. So good for you guys. The rest of you, it's like, I don't like puzzles. Give me something else, a little more structured. Yeah, it's coming. It's coming. So I just boxed the right answer on this one. Wow. Okay. I'm not going to do all of these with this method. I want to do, I'm going to pick one more because the other method, I would say majority, more than 50% of the students like the other method. Majority usually do. Okay. I want one where the signs are going to be different. I'm either going to pick this one. I like this one. I like this one because this is not in order. So I'm going to do this one. And then Jan, you can maybe work on some of these possibly. And I'm looking over here. They might even be the same ones. Yeah, they're all the same ones. So what I'm going to do is in 6.4, I'm going to do the same 2, maybe 3 problems, but with the other method. So you can see how it works. And then Jan can work on the other ones. All right, so why did I pick this one? Because the instructions said on the beginning, descending order of power. That's not in the correct order. So 3x squared, subtract 13x, subtract 10. Oh yeah, do that first. And then you got to ask GCF, question mark. Nope. All right, so it's no. Then you're going to go to parentheses, and you're going to look at the choices for 3. Well, luckily, there is one choice. Choices for 10, 1 and 10, and 2 and 5. And then pick a pair. Well, 1x and 3x, easy. I'll pick the 2 and the 5. Okay, 2 and 5. And signs. Okay, so the signs have to be different. So where do we put the positive, negative? It's almost like, I don't know. Positive, negative, I guess. I don't know. Try it. Maybe these have to be reversed, possibly. Okay, the outer and inner. Okay, so that's 6x minus 5x. That certainly isn't negative 13. It's not. Oh, okay. Then I was highly recommending leaving the first ones the same alone, and then switch the back numbers. So 2 and 5 goes to 5 and 2. 5 and 2. Okay, just keep the plus there and put the minus right there. And now do outer, inner. That's 15. X minus 2x is 13x. Hey, I got the right number, but I got the wrong sign. I got the right number, but got the wrong sign. So the easy fix, swap the signs. It'll work. I got the right number, but that's a positive, that's a negative. So swap the signs and you're done. That means go x subtract 5 and the 3x plus 2. Look at negative 15 plus 2, negative 13. Okay, now the other method might feel complicated at first. Once you start, I don't know, practicing with this method, I think most people like this method better. Call it the grouping method. Sometimes a long time ago it was called the British method, which I have no idea why the British. These are the hard ones. Still same thing. Okay, factor off the GCF. Still want to do that first. All right, so here's where it starts being different, right here. All of this right here is what's different. So after you factor off the GCF, if there is one, then what you're going to do is in descending order of power, you're going to multiply the first and the last terms together. I say terms, I'm talking about the numbers. So 2 and 15. 2 times 15 is 30. Okay, great. Now what, Jeff? Well, what we want to do is list all the factors of the product. I want to find all the factors of 30. 1 and 30, 2 and 15, 3 and 10, 5 and 6. 6 and 5 is the same as 5 and 6, so you don't need to duplicate those. Okay, so I looked at all the factors of the product, and then what you're going to do is choose a pair. It's actually, see, not a pair, choose the pair. Look at choose the pair. There is generally the pair. It's like, there's the magic pair. That gives you, I don't know, grammar. Choose the pair that give you, I think might be an S in there. English majors, you'd have to help me out. That gives you.
Yeah, it's an S.
The middle coefficient of the original trinomial. Oh, pick a pair that gives me this. Pick a pair. No, no. Okay, by the way, you pick a pair that could either add or subtract. That gives it to you. Sometimes you're looking here, oh, there's the winner, which is true. But it could be that you subtract them and it gives you that middle. So be mindful of that. Okay, so I'm picking that one. Then what do? You're going to rewrite the trinomial using the pair, using this, to replace the middle term. Oh, the middle term is 11x. 11x. You're going to rewrite that, you'll see on the next page, as 5x and 6x. On the next page, you'll see that. You're taking the middle term, you're finding, hey, 5 and 6, that's the number, that's the pair, and rewriting it as 5 and 6. 5x and 6x. Okay, so there it is, 5x and 6x. Okay, now what, Jeff? Grouping, because it's 4 terms. 1, 2, 3, 4. Grouping. Pick the pair, always put a plus sign there. Always. GCF. Okay, pull the X off. Pull the, I guess 3 off. Look at the middle, or the binomials are the same. Yay, that's exactly what you want. Write those down once, write down the leftover, you're done.
Where did you get the 15?
Okay, well, this 15 came from the original problem.
Oh, okay, thank you.
Uh-huh. See, that's the same problem as I did. There it is right there, same problem. That's the same problem. I'm just showing you now 2 different methods. This one, how long did it take me to get to the answer? Look at, and that wasn't it. Look at all, it took me a long time to get to the answer. There's the answer right there. That's the same answer I got as I did right there. Same answer. It feels like it's a little quicker and a little more structured, this grouping thing. Feels like it. Okay, now that one. I think that's the same one as I did over here. Oh, there it is right here. And help me with this one. Was it two chances, 3 chances, and then we came up with the right answer. So 3. Right now, I'll show you how to do this one. It might be less work. So the first step is to take the last numbers, I mean the numerical coefficients, 15 and 8, and get a product, 120 if I'm not mistaken. That's 40 plus 8, 120, and then list out the choices of 120. Okay. All right, well, that's not going to work. What you're doing is you're listing them all out to see if you get 22 somehow. Well, that's certainly not 22. I do them in order. I start smaller to bigger. 1 goes into it, sure. 2 goes into it, okay. 3 goes into it. Does 4 go into 120? Yep. Does 5 go into that? Yep. Okay, now I'm starting to think, I don't know, 5 times what? I just take my calculator. Oh, 24. See, I'm still looking somehow for 22. Yeah, none of these combinations give me 22. So keep going. How about 6? I'll just go 120 divided by 6. Oh yeah, okay, so 6 and 20. That's still not 22. How about 7? I don't know. I don't think so. No. How about 8? Well, I don't know. Oh, 8. Okay, let's try that. 8 and what was it, 15? Yeah, that's 23. It's close. It's 23 though. How about 9? I don't know. 9 divided by 9. No. How about 10? Well, of course, 10. 10 and 12. That's it. That's the pair. I wanted 22. I got it. So then over here, you're going to rewrite this problem right here as 15x squared, but you want 10x and 12x. Now 10x and 12x, the only way that you can get negative 22x is if they're both negative. Negative 10 and negative 12 is negative 22. And then you go plus 8. And now you do the grouping. So pick a pair here, parentheses, sure, why not? Always put the plus sign right there. You're right, Jeff. I almost made that mistake. Put the negative with the 12. Now you do the GCF. Looks like there's a 5 and an X. 3x subtract a 2. Looks like there's a 4. So plus 4, negative 3x plus 2. Oh, so close. They're not exactly, but they're so close. But guess what you get to do? Because they're opposite signs. See, that's a negative, that's a positive, that's a positive, that's a negative. Because they're opposite sign, you could have taken off, which I'm going to do right now, take off the negative off of both of those. So factor off the negative. One of them, this one here. And when I factor off a negative, that's like a positive -4. Factor off a negative. There's a positive left over here, and there's a negative left over here. Because look at -4 times -2 is +8, and that's -12. Hey, that works. And now they look the same. And you go 5x subtract 4, and that is the answer that we got doing it the other way. Now, this one was a lot of work because look at how big that number is. It was a lot of work because of all the choices. So the one that Jan helped me with, maybe that was just as much work as this one. And that's why you get to pick your method. Pick the method that you want for your homework. Because I'm not going to look at your method. Maybe the grouping, not the grouping, the group quiz. I don't know if I'd look at your method except, hey, what method are you using? Because it doesn't make any sense to me. Maybe I'll do that because your answer was wrong. Or there was no method whatsoever and your answer is still wrong. Like, here's the problem. Here's your answer. Nothing leading up to your answer. How'd you get a wrong answer? You didn't even check it. See, couldn't I check this? By foiling. I said, well, there's only one other problem I did, and it's basically the same idea. The other one, I had to arrange it in descending order of power, and then it's the same idea. So you've got two real good examples from me, and then your textbook in 6.4 gives you about 4 examples, so that gives you about 6. And then Jan could work out some of the other ones, and you can tell her which method you want her to mess around with today when you're in her session. Any general questions? I do have a little quiz. It was planned originally. I know he says, oh, shoot, really? Yeah, it's on 6.1 and 6.2. I think there's 5 problems. So it's a good review for you anyway, for the little quiz. But any general questions before I do the little breakout rooms to allow you to talk to each other and try to work those out? And then you can go see Jan. Anything about today, what you saw? Okay, let me open up that. I think it's called daily quiz number 5, maybe? No, maybe not. Yeah, I think it's number 5. Make sure it's the right one. Yeah, 5 problems. Okay, I just turned it on. Check out your Canvas and see if you, number 5. Thumbs up, thumbs down, anybody? Not seeing it, Russ is not. Okay, Randy's seeing it. Okay, Matt is also. So it's under daily quiz number 5, probably under assignments. Russ is still looking. Evelyn's still looking.
It's there, Jeff.
Okay, see it, Russ? Okay, good. Okay, so this is what you're doing. You're going in there and picking the right answer. You guys can work together. And then when you're done, I'll be hanging out here for a while. If you need questions for me answered, or Jan, go to Jan's. And she probably put it in a chat about the
Yeah, it's
link
there.
again. Okay,
Yep.
thank you. Okay, so let's do this breakout room. Okay, so let's see, do 5.
Just a reminder before you go into breakout too, you guys, Gordon just texted me and he's waiting all by himself. So if you want to go see Gordon, do that too, because he's there.
Thanks, Jan, for that announcement. Did you get moved, Jan?
Getting there. I got everything out of my place yesterday.